is the simplest. It doesn't get any simpler than this. This is called a primitive evolutionary term, for the simplest form of energy harvest that we know anything about. And so if you're talking about some kind of living cell that has a storage form of energy that can be converted into usable form, as far as anybody knows, there isn't anything simpler than this that can do it. And so this might be a good place to look at how did life originate? What would have to be involved in making the simplest of all of the energy harnessing systems? And what we're going to do in this process is take a sugar molecule. This is the ball and stick model, and usually you can draw it as a straight chain, but usually it grabs hold of its tail, so to speak, makes a six-sided figure like this, and the formula for it is C6H12O6. Now you might notice as you look at it, I'm going to see how this writes, that would be like C, there's 6 of these C's, and then what? H2O, water, 6 times. Do you get an idea of why they call sugar a carbohydrate? And so it's really a carbon hydrate. It's a carbon molecule with a water molecule attached to it, an H and an OH. You can write water as either H2O or HOH. So here's a carbohydrate, a carbon with the elements of water attached to it. And that's going to be split essentially in half to form 2 molecules down here of pyruvic acid. And so this process is sometimes called glycolysis. Lysis is splitting, and so this is splitting sugar. And as a result of this, we're going to harvest a little bit of energy, ATP, like converting gasoline from the generator into electricity to run all the appliances in your home. We're going to convert sugar into ATP that can run the muscles and the nerves and the digestive system and things like that. So we'll take a look at the details of this, and remember, you just get to enjoy. You don't have to remember all of these things for the test and so on. Well, we'll break it down into processes, and the first one ought to be surprising, in fact, even stunning. Okay, the first thing that happened, and if you extend this a little bit, it's called fermentation. And this is anaerobic. For this process, oxygen is not required. But the first thing that happens, now I'm going to use a little shorthand symbol for glucose, just a 6-sided figure with the oxygen at one corner of the molecule and the 6 carbons sticking up like that. The first thing that happens in burning glucose for energy is to use a molecule of ATP. Well, that puts us in the hole right away. We want to make ATP. The first thing we have to do is use ATP to make ATP. Well, from a creationist point of view, that's no problem. If you know what your goal is, okay, then it makes sense. If you don't have any goals, then how in the world could this step ever occur by natural selection and be saved because it made the molecule more fit to survive? You've used up a molecule of energy and you got nothing to show for it. And so Darwin made a statement, that you've heard before, that if it could be shown there was any feature of a living thing that could not be built up one step at a time, what? With each step having greater survival value than the step before, then my entire theory would be proven false. All right, tonight we're going to prove it false about 12 times. And if you go through the rest of it, it's been proven false thousands of times. It's just the evolutionists haven't quite got caught on to this. So the first thing you have to do is activate it. And so, like I said, the nice thing about glucose is it doesn't explode in your face. Although I almost had it explode in my face. Okay, you're talking first-year teacher. I wish I'd have tape recorded that because I could have written a book, everything not to do your first year of teaching. But, I'm a science nut, and I wanted my students to really get enthused about sugar, and that sugar, was produced by green plants using sunlight, and sugar was a tremendous source of energy. Well, of course, I know my students are thinking, it's sitting there. in a cup on the table. It just sits there. It's a little white grainy stuff. What do you mean that's got the energy of heat and light? What do you mean that's storing sunlight energy? It's just gritty white stuff. And so I decided they needed to see for themselves that sugar stored the energy of heat and light. And so all you have to do is take a little sugar. In fact, there is, little science books have this sugar rocket you can make. So you take some sugar and you put it in a test tube and you put in there some potassium perchlorate. That's the oxygen source. So you're going to burn the sugar with oxygen, so you put that in there. You put a little manganese dioxide in there as a catalyst to make the reaction go faster, and then you just give it a nudge. So I put this in the test tube and put it on a clamp, and here it is. And, I've watched the students watch me do this. And I taste the sugar. It's just regular sugar out of the cafeteria. And I put it in the tube, and I slide the Bunsen burner under there. Whoosh! Boy, oh boy, just incinerates, and fire, and light shoot out the end of the test tube. And of course I step back, the students are totally awestruck. And so I'm already feeling really good. Well, I have 5 classes in a row of biology. And so the first class, it was fabulous. The second class, it was fabulous. The third class, it was fabulous. But I'm using the same test tube over and over. By the fourth class, I noticed the test tube was full of a lot of burnt sugar. It's got kind of a honeycomb appearance, but still worked for 4th period. 5th period. Now what I had was a lot of surface area added to this. And of course a lot of the catalyst was stuck to this gooey burnt sugar in there. So I mix the stuff in front of the students, ready for another dazzling demonstration of converting sugar into heat and light. And I put it in there and I start to slide it toward the Bunsen burner and I see the spark. So I dive over to one side of the room, blows the test tube apart, sprays burnt sugar, and sets the American flag on fire. Okay. Okay, you don't want this to get out that you had to talk by a flag burner, okay? But let me tell you, this simple little molecule here really does store the energy of heat and light. It's packed in there. But it's in a form that has to be prompted into action. Nitroglycerin is a little meaner. You've probably seen or heard stories and movies, somebody's moving nitroglycerin and you shake it, boom, it blows up. Well, you can drop, a sack of sugar, you don't run it. It's just going to sit there. In fact, it's just kind of a lump. In fact, literally sometimes. And so in order to begin to use it, you got to kind of prime it. And so now that's good because you want sugar to be stable. You want it to have a lot of energy, but you don't want it to blow up in your face. And so you're